If you're working with a builder's level or a transit or a theodolite, using those instruments involves inevitably using some sorts of tape measure to make sense of the optical crosshairs in the instruments. In this video, I'm going to focus on the readings, the math behind these Surveyors rods, and compare it with that of a tape measure, an ordinary tape measure that is marked in metric on one side. So these are centimeters, 30 centimeters, 31, 32, and there are millimeter lines between there, and feet and inches. So that's 1 foot, 1 foot 3, 2 feet, you get the idea. So this tape measure is a standard metric on one side, feet and inches on the other side. This feet and inches might be known in some markets as imperial or standard. These Surveyors rods are different. So, and not only different that, hey, this one has black numbers on yellow background and this one has black numbers on silver background. No, it's not that simple. So let's take a look at this Surveyors rod. Both Surveyors rods, just like a tape measure, of course, they start on the bottom, 1 foot, 2 feet, same here, 1 foot mark, 2 foot mark, 3 foot mark higher up there. Same here, as it is folded, and this is made in Sweden here. Okay, so don't blame it on the Swedes or the fractions or whatever. I'm just showing you how to make sense out of these because they are tricky. So this one, as it is folded, 11 feet, 12 feet, 13 feet. Now, you might be thinking, okay, if this one has feet on it and this one has feet on it, then these must be inches. Because look at them. They look like inches. They are about an inch there. And an inch, by definition of an inch, is about this much. Not my thumb. Whoever's thumb was standardized, don't worry about it. So they look like these are inches, but they're not. Let me show you this. Look at it. The 1 foot mark here lines up in the center of this longer mark here at 11 feet. So that's a whole foot. And that's a whole foot mark there. And likewise on this silver one, it's the same idea. You can see the foot marks here line up with each other perfectly. So 1 foot, 2 feet, 11 feet, 12 feet. So why aren't these inches? Very simply is look at the red numbers on a normal tape measure. 1 foot 1, 1 foot 2, 1 foot 6, 1 foot 7, 1 foot 8, 9, 1 foot 10, 1 foot 11, and then 1 foot 12. So 12 inches make a foot, so that's 12 feet. Not so on these two guys here. 11 feet, 11 foot 1 inch, 2 inch, 3 inches, 4, 7, 8, 9. Where is 11 foot 10? Where's 11 foot 11 inches? Same here. 1 foot 9, there's no other numbers after 9. Where is 11 inches or 10 inches on this? Well, these are not inches, very simply. These are decimals of a foot. So, very simply, this is 11 feet, 11.1, 11.2, 0.3, 0.4, 0.5, 0.9, 12. It's that simple. These are not inches. So how big is 0.1 of a foot? It's a little longer than an inch. If I line up the tape measure on it, actually I might be easier on this one. On both of these cases, the number in the middle of the longer lines, the longer lines indicate the number that's in between them. So this is 11 feet. These two longer lines indicate the number in between is 0.1. These two longer ones, 0.2, 0.3. So the numbers are oriented this way as opposed to printed sideways like on this one. So if I put one on top of another, you can see that 1 inch on the yellow tape measure, and it doesn't really matter where we start. we can start with this alignment here. There you can see that this 1 inch, this is an actual inch, it's shorter, and this one is longer. A tenth of a foot, a decimal foot, is longer than an inch every time. Everywhere you look. Now it's missing there. Okay, so these are decimals over feet. On both of these, they are not inches, so that's how they read. So what about these? So that's 0.1, 0.2. So what about these little lines in between? Now, usually on tape measures, there are even number of smaller lines on either side. For example, if you look at these millimeter lines, anywhere you have 4 millimeter lines on this side of this longer line, and 4 millimeter lines on this side of this longer line here, between centimeter marks 4 and 5. So 4 millimeter marks there and 4 millimeter marks there. But on these ones, that idea is not present. Take a look at these smaller marks. So there's 2 shorter ones, a longer one, and then 1 shorter one. Same here. 2 short, long, 1 short. 2 short, long, 1 short. So what's going on here? Well, they divided a tenth of a foot into 5 parts. So there's 1 part, 2 part, 3 part, 4 part, 5, the 5th one. Okay, so just look at we're counting on a tape measure these jump lines. Okay, so 5 parts are to the tenth of a foot. So what is the reading here on this particular one? It is 0.0. Okay, now my number doesn't fit there. 2. So this is 0.04. Sorry about this ugly 0.4. This is 6. That is 8. 2, 4, 6, 8. So this is 6. This is 0.62. This one is 0.64, 0.66, 68, 70. Because with decimal numbers you can write trailing zeros. Sorry about this really ugly 0 there. You can write trailing zeros after decimals. So I hope this makes sense. And this is 0.62, 64, 66, 68, 70, 72, 0.72, 74, 76, 78.80. Over here, same idea. We can pick it anywhere. This is 11 feet. 11.1, 11.12, 11.14, 11.16, 11.18, 11.2, 22.22, 24, 26, 28, 30. Okay, I hope that makes sense. Now, if that wasn't tricky enough already, there's more to it. When I flip it around, this is standard feet and inches. These are now inches all of a sudden. Look at the spacing of the lines between 1 and 2 units, even number of short line, longer line, shorter line, longer line, and all of a sudden you've got all your 10 inches, 11 inches back. So how do you know that this is decimals of a foot and this is inches? Very simply put, the foot is divided into 12 parts here and only 10 parts here. So you have to watch it like a hawk. That's also why they colored it differently. So this is black numbers on silver and this is black numbers on yellow. So the person doing the instrument readings, they can tell just by the color, if that helps, if you're not colorblind, that this side is decimals of a foot and this one is normal feet and inches. So this is 1 foot 6 inches and a quarter, 1 foot 6 and a half, 1 foot 6 and 3/4, 1 foot 7. On the opposite side of this, metric. So this would be 10 centimeters here. So between that mark there, 50, and that mark there, 60, if I line it up well, you can see that this is 10 centimeter section of the tape. So this is in meters, this is so 10 centimeters, 20, 30 centimeters, or if you're going in meters, this is 0.1, 0.2, 0.3, 0.4. That's what they mean by those with 0.4. I know that looks like a comma, a decimal comma, not a decimal dot, but they didn't want to make it look like a speck of dirt. Okay, so that's why they went with a small triangle. So that's 0.5 of meters. So these are centimeters, and sorry, this is 10 centimeters, and these are centimeter lines on it. So this is 41 centimeters, 42, 43, 44, 45, 46, 47, 48, 49, 50 centimeters. Or 50 centimeters is right here, half a meter, depending on how you look at the decimal. So that's 0.5, half a meter. Now there's one other detail that's important here. The shapes of the lines on either one of these surveyor's rods is important. So let me put you down here, and I can explain how the shapes of these painted lines are meaningful. Let's start with the 1 foot mark here. Right here at the top of the line where the point is, right there. This is exactly where 1.0 foot is. It's a slippery surface, so bear with me here when I write on it. This is exactly where 1.0 foot is. The decimal place is important. You might say the 0 can be omitted, but it's going to actually help. And yes, it could be omitted, but it's going to help. So when you're looking through the instrument, either builder's level, whatever, and you see the crosshairs, the vertical can be anywhere, but the horizontal, when the horizontal crosshair is sighted right here, this is exactly where 1.0 is. Over here at the long hair, at the long point of this line, when your horizontal crosshair is going through here, this is exactly where 1.1 is, and likewise 1.2 is right here. So far so good. Now, each of these painted lines equal to 0.02 foot. So, but what part of the line is exactly there? Well, the tops of the lines. So this would be 1.02 here, 1.04. The not the long point here in this case, but the top of the line here would be 1.06. Top of the line, or the top of the painted line, is 1.08, 2468, and then we are at 1.1, and it keeps going the same way. 1.12, 1.14. You get the idea. Okay, so the bottom of the painted lines here is of course the missing numbers. This would be 1.01. This is 1/100th of a foot. There, 1/100th of a foot. This is 1.03. 1.05 is right there at the long point. So 1, 2, 3, 4, 5, 6. We have everything here. This is 1.07, 1.09. And then after 1.09, it's, or that 9 is going to turn into a 10, so this is going to be 1.1, and you can put a trailing 0 here to help. These trailing zeros sometimes help, okay? So this 1.1. The next number after 1.09 is 1.1. And then here is 1.11. Okay, you get the idea. Now, what do you do when a reading is right between, say, there? Because you're going to have to interpolate the hairlines that you see in the optical device. They will fall between these painted lines. So what number is this? Well, this one is 1.12, 1.14, 1.16 here, 1.18 there. The bottom of this one is 1.17. So the number between 1.16 and 1.17 is exactly 1.165. And if this hairline was a little lower, then it's 1.163. It needs to be estimated, because the precision of this surveyor's rod is only 1/100th of a foot, and you're gonna have to estimate some other, a third decimal digit here, thousandths of a foot. So let's have these read. And for contrast, let me show you how the readings go on this metric side of the same rod. So this is 0.5 meters. I'm going to put the decimal numbers on a piece of paper here. Right here at the bottom of this square, the first square, so we start at 0.5. And trailing zeros help, so I can put maybe 2 extra zeros here. For, looks like for no apparent reason, but they are going to help. So at the bottom of the first square, this is the square, here is 0.51, and I can put an extra zero there if I want to. Top of the square here, that's 52 centimeters, so that's 0.52, and then there's a yellow space, and there's one more square here. Bottom of this square is 0.53, top of the square 0.54. Okay, so that's 51, 52, 53, 54, 55. I hope that makes sense. What do you do when the sight reading line, the hairline, the horizontal one, is right between these two squares here, right across there? You're gonna have to estimate millimeters, and the millimeters plug into the third decimal place here in these numbers. This one has the third decimal dot as a 0. That's fine if it's right on the edge of the square. So what is the number that's exactly halfway between 0.52 and 0.53? That number is going to be, I'm going to write it here, 0.525. I hope that makes sense. So that's why this can be thought of as 520. This is 530, so that's between 520 and 530 is 525. If this horizontal crosshair is sighted a little lower, then it could be estimated as 0.523. If it's a little higher, 0.527, 0.529, until it actually lines up with the square mark here, or the edge of this square, painted black square there, and then it's 0.530. So it's really important to generate this third estimated digit. That's part of your readings, and it's understood as estimated digit. The precision of this rod is 100th of a meter, so that's second decimal place everywhere. Likewise, last one, on this side of the rod, this side of this rod here, with inches on it everywhere. Like I said, this would be 1 foot, 1 foot 1. So this is 1 1/4, 1 1/2, 1 3/4 of an inch. But where exactly is 1 1/4 on it? Right there at the top of the line. I'll put you back here. This is 1 1/4 right there, 1 1/2 exactly there, 1 3/4 here, and 2 inches exactly there at the top of the line. So if that's half and that's a quarter, and this is exactly 3/4, what are these on the bottom here? Well, that's 1/8 of an inch. That is 3/8, 5/8, and 7/8. Just like on a regular tape measure, you have all the major fractions. So 1 1/8, 1 1/4, 1 3/8, 1 1/2, 1 5/8. Okay. So that's how they all go in this combination. What if you have, again, a horizontal crosshair going through, I don't know, here? You're gonna have to estimate that's 1 foot, 1 inch, and half of 1/8, 1/16. This would be, if I wanted to write it down, 1 foot, 1 inch, and 16th of an inch, right there. If it's a little lower or a little higher, yeah, good luck with fractions. 1/32 of an inch or whatever you can estimate, but it's really important to estimate this fraction part again as accurately and as precisely as possible. This fraction exactly in the middle here between a quarter and 3/8 would be, let's see, that's 1/16, that's 2/16, this one is 4/16, that would be 5/16 right there, because a quarter inch, equivalent fractions in your head, yes, a quarter inch is 4/16. If you quadruple the numerator, you quadruple the denominator, so one more than a quarter of an inch is 5/16 of an inch. So that reading here is 1 foot 1 inch and 5/16 of an inch right there. So this one is difficult to read, probably the most difficult of all, because decimal digits are perhaps easier for your mind to generate or interpolate the numbers. Maybe you like decimal metric as well, but this for most people is difficult. So where do you come down on this one? Do you find this the easiest? Do you find decimals of a foot easier and not as confusing as fractions of a foot, inches of a foot, because this is 12 parts to the foot, so this is 1/12 each, and this is 1/10 each, and the 10th is larger than a 12th. And yeah, I know that 10 is less than 12, so that's another mind bender there for you. So what side of the argument do you come down to? Decimals or fractions of an inch? Let me know in the comment section below, and thank you very much for watching.